Thank you for coming to this session. This is the second session of the AI-driven networks working group. I am Hideki Nagano from NICT in Japan. I will chair this session. And so the first speaker is the Jin Gok from SNET, and the title is SNET Data and AI Workshop Outcomes. Oh, can you start now?
Yes, absolutely. So welcome back. I'm going to give a slightly different perspective on the session. So, the first session, we actually had a lot of folks talking about their research. Some of it was just pretty amazing. What I'm going to do is I'm going to take a step back, right? And one of the reasons why I wanted to give this presentation is because at ESNet, we've been looking at some of the AI investigations and stuff like that. And then the question came back to, but what problem are you solving, right? So ESNet, we are a network organization. We're not a research entity. And so the question is, we can do all this stuff with AI, but the question is, what kind of problems are you solving? And so what we decided to do was to actually have a workshop that we would pull all the folks together from across the organization, ask them to start thinking about what the problems you're trying to solve, and then we start going through and trying to figure out which problems are AI problems and which problems are not. So just a bit of background, I'm going to go through this pretty quickly. If you're not familiar with ESNet, we're funded by the Department of Energy. We basically serve the national labs. I'm not going to read this. We've been around since the mid-70s. Every year, every generation of ESNet, sorry, every generation of ESNet, we focus on very specific capabilities that we want to put into the network, right? So for ESNet 6, the one that we're currently on, that was actually finished in 2022, there were two areas that we were looking at specifically. So one was an orchestration, and the other one is called high touch, which is basically being able to look at network measurements, being able to look at every packet that comes into the network, right? So the orchestration stack actually gives us the ability to take actions once a decision is made. And the high touch gives us the ability to have visibility into what's going on into the network, right? So for ESNet 6, we built those capabilities. This was done over 5 years. So now the question is, you have the ability to take action once you make a decision, and you have the information to help you make a decision. So what is missing now, right? And so the idea here is, hey, you know what? This notion of AI can now be leveraged to basically help you make that decision and then execute it. So the first presentation done by Mariam when she was working with ESNet, that was one of the first few things that we started talking about, right? How do you actually take the information that you get from the network, make a decision, and then optimize your traffic engineering? That was a very specific example of a very network-centric solution, right, using AI. So the question is, we kind of started thinking, well, for ESNet 7, so we're starting to look at our next generation network. We're starting to do the planning. There are 5 areas that we're looking at, right? So capacity and resiliency, network application service composability, advanced wireless, in-network storage and compute, and then artificial intelligence for IT operations. The big 2 areas that we're thinking of, right? So in terms of capacity for resiliency, that's really infrastructure for AI. AI and quantum are the 2 biggest initiatives that the Department of Energy is actually pushing, right? They're spending billions of dollars in the area. And so what happens is that one of the things that they're looking at is trying to figure out how do we actually leverage all the computing facilities within the Department of Energy. So there are 3 supercomputing facilities in the Department of Energy. How do you actually use that to do distributed learning and things like that? So all of a sudden, the network becomes an important aspect because you have to do, right, as you do forward and back propagation for your learning, you need to be able to have networks, and you can't just use, standard networks. There are very specific constraints that you need for. So in terms of capacity and resiliency, that's really, infrastructure for AI. And what we're looking at for ourselves is really the AI ops, which is the AI for infrastructure. How can we leverage AI to actually run our infrastructure better? So I'm going to jump into the workshop that we ran. This workshop was actually run last week, right? So it was run Monday through Thursday. I did an initial readout on Friday, and so I'm actually presenting to you what was actually done. So this a lot of the information I'm presenting in terms of our readout and stuff like that is still, a draft form because we're going to be spending the next month or 2 months to be able to write up the report. But I wanted to give you just a general idea of things that we are looking at from an organization that is, I'm so sorry, that is engineering focused, right? So one of the first things I did, I thought, well, if it's an AI workshop, why don't I use AI to actually generate the welcome message? So I took our workshop objective statement and I took the agenda and I fed it into ChatGPT, right? And it actually came out with this. It says, welcome to the ESNet Data and AI Workshop, where the boundaries of innovation and discovery are waiting to be pushed. Over the next few days, you'll be part of a dynamic community of experts, researchers, and practitioners passionate about harnessing the power of network data and artificial intelligence to drive meaningful impact. This workshop offers a unique opportunity to delve into the latest advancements and trends, explore the vast potential of these fields, and engage with renowned speakers, collaborate with fellow attendees, and learn from their experiences and insight, ultimately driving positive change and shaping the future of our world. Now you can tell this is done by AI because no engineer would write something like this, right? And so it's really impressive to just take a really simple statement, says this is what we want to do for our workshop. This is what the agenda looks like. Give me a welcome message. So this was the statement that I put in, right? The objective of the Data and AI workshop is to identify challenges within ESNet that can be addressed through data-driven methods. This will help define ESNet's data analysis requirements and shape its AI strategy, guiding data stewardship efforts and the direction of AI research and AI ops exploration for ESNet 7. So this was basically the prompt that I put in, and it generated that message, right? I'll give you a structure of what the workshop actually looks like so you can kind of understand how the thinking and how the information actually progressed. So the first thing we want to do was, what is the problem we want to solve, right? So understand the problem and the questions. Then the next step was to figure out the data that we actually have. So we collect a huge amount of data. The question is, can we actually use this data to solve our problems? Is there gaps in the data? Are we not curating the data correctly? Do we need metadata from this information that we don't actually have? So we did a session just understanding our data. And then the third session was kind of interesting, right? So understanding AI. This is where we actually got a panel of 6 folks to come in. They were both from industry as well as from academia. And their job was to explain how AI actually is used, what should it be used for, what it should not be used for, right? One of the things that in our organization at least, right, because AI is such a big hype around, when DOE says, AI is one of the big initiatives. Any problem that you think of, everybody goes, we can solve that with AI, right? Now the question is, should you be actually solving that with AI? And the answer sometimes is no, right? There are very well-known methods and statistical analysis that you can run that will give you deterministic results. Why train an LLM or do machine learning to do this? I mean, you have an actual way of solving the problem without actually going through all that. So that was actually an interesting session because we actually had folks coming in, like for instance from Meta. So they were not actually, it wasn't like a commercial company, right? We have folks coming in from Meta saying how they actually use AI to solve some of their problems and what did they actually use AI for. And so that kind of gave us a framework to understand, yes, these problems are AI problems, and these problems really, we can kind of just do, some kind of linear regression or something like that to solve that problem. So once we did that, session 4 was really to take all the information and bring it together, right? So what we did was we developed this thing called work packages. For every work package, it is a problem that you want to solve, the data that you need, what kind of analysis that you want to do on this, or what kind of analysis that you need to be able to solve that problem. And then when we were done, we did a cross-cut. And so a cross-cut essentially is we kind of look through all the work packages and we say, hey, if we solve this problem, we can basically take care of, it's part of, like 80% of the work packages, right? So if we solve this problem, it will be able to help with these many work packages. So that was kind of the way the workshop was run. We had about 50 people across the organization. So we had representatives from every group within the organization, right? So we had engineers, we had people from finance, we had folks from our business office, we have project management. And the idea here was to get people to come together and just say, what is your problem? How do we solve it? What kind of data do you need? What kind of analysis do we need to start figuring out? The folks in the front are all our panel folks. So they're the ones that came from academia as well as the commercial side. So here's the outcomes, right? So out of the 2.5-day session, we came up with about 29 work packages. And the my initial feel going into the workshop was, hey, we want to solve these really hard network problems, right? But what we realized were a lot of the problems that people were highlighting were really simple problems. Things like we have data in about 50 different places. If I want to look for something, I have to go look at 50 different places, and they're not all in the same formats. Some of them are in databases, some of them are in Google Docs, right? Is there a simple way that we can do a search across all this information, right? There are things like, if I wanted to basically ask a question, could I actually use natural language processing to be able to determine what the query should look like across these 50 different data sources? So they were really simple and mundane problems. There were some that were more like grand challenges, right? Which is can you run the network at 80% efficiency, right? Typically networks we run at 50%. That's about the max. 80% is a bit tricky because resiliency issues and things like that. So, but primarily most of these were more mundane questions, right? Day-to-day things. How do you get your job done? What can you use AI, and how can you make your life simpler? What we did was, after we created all those work packages, we wanted to do a crosscut. So we had 4 practice areas that we wanted to focus on, right? So across all those work packages, we said, look at what the data management requirements are. Look at what the analysis, if there's any classical analysis that you want to use, right? What AI methods can you actually employ? And then what the user experience should be, right? So for every one of those 29 packages, we kind of went through and we basically outlined and said, these are the 4 areas that we want to kind of focus on, right? And see how can we figure out commonalities, right? So I'm going to give you a really initial cursory synthesis of what one of the groups came up with, right? So there are actually 5 areas that after we did this crosscut analysis, the AI group actually said, hey, there are 5 areas that we need to focus on, right? The first one is data management and integration. So in here, there are 4 work packages that are related specifically to data integration, data management integration, right? One of the big things that we realized was that we don't have consistent data models across our multiple databases. So it makes, asking those, what happens is when you ask a question, right, unless you know exactly the right fields and the right question to ask, the information that you get back is not the same. Because what happens is in one database, your router name may be called a node, right? In another database, your router name may be called a router. So if you just say, I want router names, then it just says, oh, I'm going to look at routers, but all the node information doesn't come to you. So there are things like that that are very simple in terms of ontologies and just having a common data model across all our databases, right? Normalization and to ensure data quality, completeness, and interoperability. And then providing a unified single pane of glass that allows the AI tools to query across all the diverse systems. So one of the things that we realized was we have a lot of data, but unless you're able to organize that data, it's essentially useless to you, right? And again, data consistency is important because garbage in, garbage out. So this was one of the big areas that we wanted to focus on. The other one was on AI-driven network operations and automation. So the idea here is that there are a bunch of things that we can actually get AI to do for us that are reasonably simple, right? So automated alerting and anomaly detection, right? Like some of the other presentations they talked about. Rule correlation and root cause analysis, right? And predictive and preventive maintenance. So a lot of this is really operations towards, configuring a network, running a network, monitoring a network, right? And the general idea here is how can you actually use AI to basically allow you to go beyond human scale management, right? So we have the automation tools, we have all the monitoring and stuff like that. When things pop up, right, when in networks, because there's so many dependencies across layers, when you have one error, you may have like 15 different alerts that come up, and then you have to figure out from the 15 which is the actual root cause, right? Because it just trickles up in cascades. And so things like that, the idea is to kind of look at AI to be able to resolve some of that for us. The third focus area is really on lifecycle and knowledge management. So one of the things is, we talked about data, right? And the question is, at some point, this data might be old, it might be deprecated, you don't want to use it anymore. we are really bad about going back and curating data, right? So we're good at generating data, but after we generate the data, we just forget about it, right? And what happens is when we start looking at using AI to train stuff, there might be data that was 10 years back that we were running on infrastructure that was very different from today, that we really don't want it to be included in the training set, right? But we're very bad about going and go like, okay, this data is now, it's now deprecated, we should get rid of it, right? So there are things like that, right? Capturing institutional knowledge in one place. When I started ESNet, that was almost like 28 years ago, right? There were maybe about 32 of us. And essentially all the information about the network and stuff like that could be kept in the heads of 4 or 5 engineers. Today we're about 150 people. Our network is much larger than it used to be almost 30 years ago. The problem is that not everyone understands how all the network runs. And the problem is that unless you document all this, you're not going to know. And so you have to go to the right people to ask. And sometimes, if you're new, you don't know which person to ask, right? So being able to kind of capture that is kind of critical for us. Automated documentation, and then applying natural language processing methods to be able to kind of scan through a whole bunch of things. So we get, we get about 100 plus tickets a week, and just being able to use a natural language method to be able to parse that and say, I want to look at all trouble tickets that are associated with a specific outage, right? Right now, today, that's not very easy because you got to read through each of the tickets and then you got to make a decision in your head. Okay, yeah, this is, you have to categorize it yourself, right? Focus area 4, service configuration and automation. Services and configuration automation. So this kind of goes back to kind of the first presentation with Mariam talking about Hackathon and things like that, right? The idea here is how do you actually automate these the automation of the configuration processes that we have, but make it in a smart way, right? So one of the things that we're realizing is we have automations, processes, but if you're a senior engineer versus a junior engineer, you actually use those tools a bit differently. And in some cases, the configuration actually is slightly different, right? Even though it's the same tool. And it's just how you actually, how you actually work with it, right? And so the idea is that we want it to be consistent, because at some point, if someone else has to come in and look at the configuration that you wrote, and you go like, what? I don't understand this. I understand this one, but why do we do this, right? So what we're looking at is potentially using AI to help distill it down, so that way we can actually check for consistency. And then the last one is more on support. Right, so again, there's this whole idea that everyone's excited about AI and things like that. How do you actually promote that within the organization? Right, so we're talking about building an AI sandbox. We're looking at LLMs for to be able to parse some of our external communications and tickets and things like that. And really, there's a whole set of challenges that we face, right, in terms of privacy, compliance, adoption of workflows. One of the things that we're very fortunate from a national lab perspective is that some of the tools that we have is local to our scope. So the message, the earlier on, the welcome message that you saw, I actually didn't use ChatGPT. We actually have a version of ChatGPT that is institutional, right? So we can put information in there that is proprietary and not worry about it being leaked out, right? So we can actually run certain queries against proprietary data that we have and not worry about, this now all of a sudden it becomes, part of OpenAI's, database and things like that. So we're very fortunate to have that. And these are the kind of areas, these are the 5 areas that we're looking at. The next step for us is really to kind of take the output and go through it a bit more carefully, and then we're going to generate a report, probably within the next 30 to 60 days. So I'm at the end of my presentation, and I thought I'll leave you with this quote. It says, if you're going to bring to bear on some really big problem the same things that everyone else has been trying, you shouldn't expect to get better results than everyone else. And so this was Astro Teller. He's the Google Innovation Chief. And the idea here is that, use AI to your benefit. Don't use AI just because you have to, right? So, all right, thank you.
Thank you. Are there any questions or comments? So I have one question. So yeah, so the problems or challenges we have to solve, and you corrected, you think in the workshop is quite important. So and after so now from now, do you have any plan to solve such challenges or so any plan for work packages?
So let me understand your question. So I think your question is, do we have any plans to work on the work packages? Is that correct?
Yeah.
Yeah, okay. So the short of it is we're basically going to take the work packages, we're going to formalize it, and then we have to prioritize, right? So 29 is going to be tough for us to do all of it, right? So we're going to look at them and we're going to decide what the cost benefit of each one are, and then we'll prioritize, and then we'll say, okay, maybe the first 5 we'll start working on this, in the next 6 months and things like that. So that will come later on. Right now, it's just a lot of it's the information and requirements gathering.
Yes. Yes, please. Please, go to please use the mic.
AI models, they are normally based on the data. The data is actually data-driven systems. Did you use any data optimization techniques? Like if you get data, and is it filtered and optimized, and how it is done normally?
The answer is yes. So it depends on what data sets. Again, so we have a huge amount of data sets, right? In terms of things that are coming out from the network, things that are coming out from our trouble tickets, things that are part of contracts. So some of it is curated, others are not, right? But I think one of the things that we realized was there are gaps in how we curate the data and how we actually normalize it across different data sources. So again, what I'm saying is that, yes, we do some of that, but really it's not done in a fashion that is, organizational wide. And so that's a gap for us. Yeah. Yes, sir.
Yes, thank you for the talk and looking forward to read the reports. I saw you categorize this into 5. So do you have any other categories of the 29 work packages and
Yes.
by what group?
Okay, so the five focus areas that I gave was basically that came out of only one of the practice areas, right? So we have 4 practice areas, and the idea is that each of them will look at the problem a different way. The one I presented was basically the folks that were specifically targeted to look at AI methods, and they said, based on AI methods, what are the 5? What are the 5 areas that you need to worry about? So those are the 5 that came out, right? The folks that come out from the user experience group, their 5 focus areas are going to be slightly different because their focus is really on how should you be interacting with the data as opposed to, we need to have data consistency, and they're not worried about that, right? It's more on the interaction and things like that. Yeah. So everything's going to be. So yeah, so it's all going to be in a report, and it's going to be yeah. So I think for the interest of time, right, we want to move on. Sorry. Thank you.
Thank you. So yeah, let's thank the speaker. Yeah. Oops. Sorry. Yeah. And the next speaker is sorry, Said Sakib Jamal from Jeju National University, Korea. The title is LLM-based IBN for resource management in SAGIN, controller, placement, slicing, and mobility solutions. Are you ready?
Yes.
Okay.
So, hello everyone.
I think you need to turn it on. I switched it off, sorry.
Okay. Hello everyone. This is me, Sayyid Saqib Jamal, and I'm here to present the research project on behalf of Networks Convergence Lab under the supervision of Professor Wanshul Song. This project was basically funded by the ROES, the regional information systems, and it was recently finished by with the help of our lab members. So. So let me start with the presentation. Basically, the outline that I'm going to cover today is related to the introduction of the satellite networks. Also, this project was totally related to the Sergeant networks. What Sergeant networks is, we will also discuss. Also, the challenges that we faced during our project, the solutions we provided, the results, and finally, we have came to the conclusion. So, as an introduction, basically, for the satellite networking part, the basic thing that we actually analyze is the global coverage. And for that case, we require some diverse applications and the network architecture. Basically, Sergeant network is the integration of three networks, that is the space, the air, and the ground network. And using the help of AI, we basically formulate and integrate the networks and tries to improve the network overall. So if I talk about the overview of the connectivity challenges in Sergeant's role for the future network, the best part was that the global IoT growth, because we know the IoT is growing day by day these days, and over the period of time up to 2030, we will have 20 billion IoT devices, and that will be demanding to scalable and efficient network infrastructure. Then secondly, we have the connectivity challenges with us. Also, the emergence of Sergeant is, the ground networks are mostly shifting towards Sergeant networks to for the global coverage and to provide the maximum connectivity to the remote areas especially. So if I talk about the SDN-enabled Sergeant network, we basically propose some solutions. Some of the solutions are related to the SDN controller. While we formulate like in the satellite network, we use the ISLs mostly. So how can we improve the ISLs in this case, and what ISLs we can that can be suitable to perform the task to? So we will also discuss that. Basically, the challenges that we have faced in our research, that the first challenge was about the multi-layer controller placement in Sergeant. The second challenge that we faced is the dynamic network topology management. And last but not the least, we faced the resource orchestration in multi-layer Sergeant. For the SDN controller placement, which is our first challenge, we basically highlight few challenges in this, which is the high mobility of the satellites, the latency and the propagation delay, the reliability, fault tolerance, the scalability challenges, definitely, because this is the most interesting challenge that we actually found out, and the dynamic traffic and load balancing. Basically, our problem is to determine the optimal number of SDN controllers. Like, what can be the optimal number of SDN controllers we can place in the satellites? It should not be more than that. It should not be less than that. Because if it will be more than the actual requirement, it will basically distort or make some distortion in during the network. So this is how we should actually place the controllers in the satellites. For these objectives, we basically require the latency, the minimum latency. We should ensure the reliability and the optimum number of controllers. What optimum number of controllers we can actually select for placement. So for this is our problem number 2. Basically, that was the problem number 1. In the problem number 2, we basically determine the efficient SDN controller placement. Where can we actually place? This is the overall network, and we basically divided it into grid forms. So where can we actually place our controller in the satellites? And these are the patterns of the satellites. This data was basically from the real time satellite network that was basically taken the TLE file. And we basically perform the experiments on that. So for the problem number 2, our objectives were related to the clustering based strategy that we have used for the efficient SDN controllers placement, and our total focus was on the low latency communication, balanced load distribution, and network scalability. For the second challenge, we got to know, like, it was related to dynamic networking topology management, in which we faced a couple of challenges, like how can we manage the dynamic link reliability, also the rapid changing of topology, the satellite sessions handover complexity, and the scalability of GNN model for global view of topology discovery. So our contributions for this case was related to, we basically developed a dynamic satellite selection algorithm to prioritize satellites' optimal elevation angles to enhance the line of sight connectivity between ground station and the satellites. Also, a novel GNN-based approach to link reliability and node aggregation for global view of the topology, because that was the main criteria of handling the dynamic topology, and an adaptive SDN control framework for dynamic topology management. The third problem that we faced was related to the resource orchestration in multi-layer Sajin. We faced these couple of challenges for this, and this was our contributions that we basically provided. Actually, these are the three challenges done by different groups in our network convergence lab, and they have actually provided the solutions based on that. That covers some architectures, some solutions, and also some graphs in the form of solution. So our solutions basically for the first challenge, that was about the SDN controller placement problem, we have basically calculated the Z score based heuristic approach. The second problem, we used the clustering based approach. For the first placement problem, we have basically taken the Z score to refine the placement. How can we actually refine the placement? This was our first problem. And the latency score and the reliability score. This was our equation that we provided, where we take the latency and the reliability score for each of the satellite, you can say. And we provided in the form of Z score, whatever Z score is, is improved score will select basically the best possible controller for the satellite. So our algorithm initially selects controller based on the average latency of satellites, which starts with the low latency satellites definitely as controllers, and it iteratively optimizes the placements. For the second approach, we have basically divided into 7 clustering algorithms to identify the effective method for efficient controller placement. That was done by minimizing the communication delay, optimizing the traffic distribution. What clusters can be chosen for the best, you can say, optimizing the traffic distribution. So here, this was our cluster-based solution for problem number 2 that we provided, which acts cluster head selection. These are the cluster head selections, which are basically acting as an SDN controller, managing the intra-cluster communication. In this, we basically took some performance metrics. The cluster quality is based upon the Silhouette score, the Davies-Baldwin index, and the Selinsky-Haber-Bus index. These are the 3 metrics that we actually provided. Based upon the score of these metrics, we basically provided our results. So the network performance was based upon the controller to switch delay, the controller to controller delay, load variance, and the traffic distribution efficiency. So for the solution of dynamic network topology, which is the second challenge, we have developed a dynamic satellite selection mechanism, also the adaptive SDN control framework for dynamic topology management. For the dynamic topology management, we have basically proposed a solution that was basically based upon the elevation angle that we have provided here. So whichever satellite comes up onto the range of the ground stations, it will be chosen as a satellite to transfer the session to. So this will totally be based upon the elevation angle that we calculated, and some of the previous researchers also discussed this thing that became our related works for this research, and this was our solution that we actually provided. So for the global view of the satellite networking part, we basically provided the GNN based model, the solution, where we have actually taken GNN as a mechanism that is actually performing the experiment in it. And here we can see in the second diagram, if the user can connect it to the ground station 1, and that has the connectivity with the satellite 3,6. I mean, this is the satellite position here. So we know in the time critical applications, the satellites are continuously moving. That's why we are talking about the dynamic topology. So after after the next instance, it will come up onto the position 3,1. So how we can actually transfer the session from this satellite to this satellite, that is also based upon this. But for that, we must have the knowledge of the overall topology of our satellite network. So for the dynamic network topology management, we propose this method where basically we provided our simulation, setting up the NS3 simulator, and we modeled our orbits, modeling satellite orbits constellation, and for that we configure the ground stations and as OBS nodes. Also implementing the SDN controller in NS3, that is the OpenFlow. We basically have the libraries in NS3 that basically that are basically also suitable for OpenFlow protocols. So for that case, we basically integrate the GNN with this in order to specify what satellites can be seen on the ground stations using the help of GNN. We cannot see the overall topology here. We can only see that topology wherever satellites are making connection with. So that is basically the part of the GNN that we actually performed here. And based upon that, we reroute the traffic to the most reliable link. What can be the most reliable link? We reroute the traffic on that. The third solution that we actually provided for our third challenge, that was basically the resource orchestration in multi-layer Sajin. So for that case, we basically used the IBN because we worked on the our intents, what intents our network is taking. This solution was also provided by one of our recently graduated lab member. He provided this solution in his thesis. So this was the overall solution that he provided. So for the working flow of IBN at Sajin, we first take the submit the intent to the IBN manager, and intent is in the form of it can be in the form of real text that basically is converted taking the help of NLP, and we make the policies based upon that, and using the help of network resource orchestration policies, we basically assure our intent, whether our intent is satisfied until the end of the task or not. So I will also give you the detail how we actually did all these things. This was just the solution to show you. So for the architecture, we basically have done here, like here, a user wants to request a VNR that should have the low latency and high bandwidth here. So after the submission of the VNR, it will go to the IBN manager, and the IBN manager will further transfer it to our IBN. And this is how our IBN will work. It will take the network resource orchestration policies, it will give it to the activation function, and then this Sajin infrastructure will be provided to our DRL network, which will take the decision. We are using the AI network here. This is the part of AI which is using in the IBN network. IBN is not basically the overall the AI solution. This is just one part that we are using in the IBN. This is the overall solution with the help of this, which is providing us the decision making for placing the VNR based upon low latency and high bandwidth. And finally, the assurance part that we are talking about, whether we will rectify whether our intent is finally validated or assured by the network itself or not. If it will provide the right assurance of our intent, then it means we have successfully deployed this low latency VNR and high bandwidth VNR. So this is our data processing pipeline. Basically, from the NS3 Sajin raw data, we are basically we are basically dividing into two solutions, because we know for GNN, we basically work on the node and node embedding mostly, and we basically take the data in the form of node and link in linked matrix. So for that case, what we actually do, we give the we provide this node matrix and link matrix information further to aggregate our function. This aggregate function will let us know if I give you in perspective of satellite, it will give us the knowledge through aggregation what satellites are actually the part of our network and what have actually made the connectivity with our, let's say, the ground station. So based upon that, it will work on this case, and then our final aggregated data frame will go up onto the GNN model that we have trained. So this is the overall architecture for our resource processing pipeline. For cross-domain VNR embedding, as I just discussed, for the two, we have given the request of two VNRs. One was related to the low latency, other was related to high bandwidth. So in this way, these VNRs are placed on all three networks of Sajin, the ground network, the aerial network, and the satellite network. And based upon that, we are basically highlighting our results. So this is the DDPG, the DRL-based algorithm that we actually use in order to take the decision for our intent-based networking, whether it's actually fulfilling the requirements of the intent or not. So basically, we have two things: the actor and the critic network. The actor first performs works on the device, and critic networks, it validates whether the actor work was validated correctly or not. So this is the overall architecture of the DRL-based. The DDPG is basically the architecture of which is the DRL algorithm we used in our network. So this is the overall architecture that we actually perform. So here we have made the use of LLM-based translation engine, because as I just discussed, how we are actually providing our intent, we are providing our intent taking the help of the LLM model, which is trained on almost like more than 8,000 intents. We have trained our T5. Basically, we have trained this model on T5 model, and the overall observations that we have taken are 8,000, on the basis of which our model is trained. So it is further transferred to the intent validation, and this is the overall architecture which I've already explained. The only addition was the LLM-based translation engine. So this is the overall network operator query and Gen AI. These are the intents that have been taken, and how they are actually translating it to the different VNR request. That is also provided in the right side diagram, as you can see. Also, these are the intents and policies that we have created. This is our sample data. As I discussed, the total observations that we have taken is 8,793, and based upon that, we made the policies. We performed the NLP here actually, and we took the intents. Just like here, you can see the policy. This is the action, and what we have to do, we need to enable data encryption, and what will be the target. So we have basically made it into the two metric form. One is the input, which has the overall intent that we have. The second one is the targeted, that makes the policies based on using the NLP, and it is basically breaking it into some words that was taken by our network, and further is performing the experiments in it. So this is the training data that we have performed. It is basically giving us in the form of how many epochs we have actually used. This is the overall information for that. Also, after training, inference, and performance analysis, we have completed our training and completed our inference as well. So based upon this, you can see this was our original text in our test data set, and this was our target data set. That was after after training the model, how much blue score it's actually providing. So it will let us know, the blue score will let us know how much it is close to the original intent that we have actually provided, how much our trained model has provided us the text, how much it has resemblance to our original text. So the blue score will provide us this thing. So these are some of our results that we have provided. This is the simulation parameter that we have used for the first challenge that I talked about, which is about the controller placement. These are some of the simulation parameters that we have used. These are some of the results that are actually telling us, because I just mentioned we have used the average latency and how many average latency at 25% failure rate. It means if the 25% satellites are failed to work, what will be the average latency of the network? If 50% failure rate of the satellite, then what will be the latency? If 75% of the failure rate, then what is going to be the latency? So these results are showing us this particular information. Also, we have made some comparisons based upon some metrics, which is based upon the average switch to controller delay that in different clusters algorithm based on silhouette score achieved in spectral clustering. We can see in most of the graphs, here the k-means clustering was performing well on the silhouette score. Also, the spectral clustering was also performing good in this case. Also, this is the result of the average switch to controller delay for 24-hour simulation, because we ran our simulation for 24 hours, and this was the result that we actually got for average switch to controller delay. For the comparison of traffic distribution efficiency of different clustering, these are some of the algorithms that we actually, on the basis of which we have formulated our results. And we can also see for this case, the traffic distribution efficiency, the k-means clustering was also performing well in this case. Also with the DB scan, this was another algorithm that we have made the comparison to. So this is the, so now for the second challenge, this is our simulation parameters that we have actually used to perform our experiments. These are some of the results that we have actually performed. This is before applying our algorithm, the GNN based algorithm. We can see we were continuously our link, because we took three basic metrics: the latency, the bandwidth, the packet loss, and based upon that we calculated the link cost. So we were actually getting to know which links are reliable to send our session to. So based upon that, we are actually highlighting this case, and here we can see after applying the algorithm, these are the results that we are actually getting. These are some of the reliable links that we are actually getting, because I have actually given the results in the form of 5 links, because we cannot see all the links here. Here we can see the best, the most composite reliability metrics, and the best link that is actually performing here is the green one, the link satellite 2 to 10 and 4.1, because it is going beyond. Also here we can see the yellow one, the satellite 3, 10 and 5.8. As we can see, it's not going, it's just performing in the middle, not going very down and not going too high. So it's actually performing good. So in this case, also for handing over the sessions, we have basically monitored the latency, packet loss, and the bandwidth. Here in this case, we can see before we could frequently hand over the sessions before performing the algorithm. This was not good actually, but after performing the algorithm, we could see there were very rare handover sessions. Like also the packet loss was not going. We were not losing lots of packets during the handover. Also, the handover were very less. It became very less after performing the algorithm. Last but not the least, in the last result section, we have basically provided the results using the help of VNR acceptance rate, the topology size, the latency over network segments, and latency over. So these are some of the results that we have actually performed for our resource orchestration. These are some of the results about the CPU utilization trends across Sargent networks, CPU utilization across Sargent topology, and QoS violation over number of VNR requests. How many QoS violations we have actually made over the number of VNR requests. So over the conclusion, we have basically developed the clustering algorithm for the first part. For the dynamic topology part, we have basically provided the solution, the GNN based approach for link reliability and node aggregation for the overall view of the topology. And for the resource orchestration part, we have basically provided the solution using the help of LLM-based intent translation. Also, the GNN, all of these things were used in that for our resource orchestration challenge. So that's all from my side. If you have any questions, you can ask me.
Thank you. So we have the time for one question. Okay.
Okay.
So, are there any questions? So let me ask one quick question. I'm not. I couldn't understand how did you calculate the number of SDN controllers?
Northbound STN controllers, you mean? Okay. Actually, that was just the case for our first strategy, where we are actually directly working with the SDN controllers. There, we are basically, as I discussed, we have provided two problems for that. The second one was related to this case. What over which region?
My question is for the first problem. Yes, we have to determine the number of SDN controllers.
Yes.
How did you calculate it?
The SDN controller part. Actually, for that, you mean you are asking the? Actually, I didn't understand your question. Sorry.
How to calculate? How to determine the number of SDN controllers?
Yeah. We are determining the number of controllers based upon Z score that we have just highlighted. Z score that we have just proposed in our solution. Basically, that Z score network is working on the latency and the reliability part for our case. That is not the genuine Z score that is we used in the statistics. Not that. This is our own proposed algorithm that we actually used for the optimal controller placement, like how many number of controllers we will use based upon the Z score.
Yeah, sorry, yes, I would like to discuss about it.
Okay, you can discuss later in TV. Okay, thank you so much. Thank you.
Thanks. Thank you so much.
Thank you.
And so the next speaker is the Sirawich Pongrawee Wongsa. I'm sorry for it's difficult to pronounce. From the Chulalongkorn University, Thailand. The presentation will be online. The speaker is ready?
Yes.
Yeah. Can you share the slides? Yeah. Okay.
Thank you, Mr. Chairman.
Yeah, we started.
Morning, everyone. Thank you for the great opportunity today. I am Silovich Ponglavi Wongsa.
I am Surisha Suptan. We are from Wireless Network and Future Internet Research Unit, Department of Electrical Engineering, Chulalongkorn University, Thailand.
Our today's topic is development of network security test bed for abnormal traffic data detection in cyber attack analysis in machine learning. So this is our members. This project aims to develop a cyber security test bed to detect and auto-mitigate DDoS attack by integrating VNet Wi-Fi, SDN, and machine learning. By the system simulates a dynamic wireless network where station can move in a real time. So we start with the question, why DDoS attack? Because from the previous years, we can see that the growing of DDoS attack is increased over the time about 100% per year. And we realize that this kind of problem is will play a big role in the future, and this is really important. As you can see from the volume, it's about 4 million requests per second in 2022-24. So we have 4 modules here. Next, we will talk in detail about each module. So first, let's start with network emulation module. So we have many open software you can use, and it's free, like GNS3 and, as you will know, Minet Wi-Fi. But Minet Wi-Fi is like the top up from Minet. So Minet Wi-Fi can use well with wireless interface and also ability of mobile device. So first, let's look at the overview how we can build our test bed. So we have our host machine that is using Windows 11 OS and install VirtualBox that have ability to create a virtual machine. So in that VirtualBox, we create one virtual machine that using Ubuntu OS. And then we install Minet Wi-Fi to build our network topology by Python script. So why we choose Minet Wi-Fi over the other open software? So because it's very fast, it can create multiple access points and many stations only in a single machine, and it can run a complex topology in a quick time. And it also have many parameters that is useful as a propagation model, that the power of signal strength will decrease over the distance. So when the station is far away from access point, then the power will decrease. And it's also work well with SDN controller. So how we configuration our test bed? We have 5 access points and 10 stations, and each access point are connected with wire links, and stations are connected with wireless links. And we set the coverage area of AP to 30 meters, and we use random walk model to move station randomly. And we also use a propagation model to determine the signal strength of each station. So the relative power will decrease based on the distance. So this is our first network topology here. And actually, it can move around, as you can all the station can move around the access point. And for example, we have a propagation model. So for example, station 1 is in both coverage area of AP4 and AP5, but it will choose to connect with AP5 because of we have propagation model that will choose the more stronger signal strength. But we face some problems. That is, it was shared memory on each station. So when we test the system and we try to attack a station, then all the station will also crash because it was shared memory. And then when we run an application on a station, then all the station will run that application due to shared setting. So how we address the problems? So we use a container net to separate each environment of the station, and then we also add features that we can move station from via command command line interface from SSH command, not random anymore. For the first time, we set a parameter that is using random walk, but now we can move from the command. We can move exactly the point we want to move. So why we choose container net? Because it can address that two problem perfectly, and container net have a leverage of Docker containers and enable to manage for better resource management. So this is the graphical picture shows difference between traditional station resource and container resource. As you can see, the container resource is separate from each other. So when the station crash, it will not affect to the other station that using container. So how we build Docker station? So we have a parameter class station as a Docker station. This is a built-in parameter. You can use it easily, and you can develop application like server outside, and you send it as a Docker image, and then you pull it in container net, so you can use it image. So our new features that we added here is move station via command execution. This is like our strategy for attacker modules that we want to move attacker station. So how we can like type the command to execute to move the attacker station. On the left side, this is the PC that simulate network topology, and we have a test1.txt file that is contain command that you want to move. And on your right side, this is attacker computer. So first you can access this file by using SSH command to that network, and then you remount the directory of this text file together. And so when you fix or when you edit the file from attacker side, then the text file from network topology side will also change. So when we type a command like move attacker 1 0 0, it means that we move attacker 1 to the origin point. So we can easily edit it by using nano in that text file. So this is our new test bed design. So we configure as we have 2 access point and 5 stations for like basic test, and then we add ability to move via remote SSH command, so we can move to exactly point we want to move, not randomly. So this is our network topology was virtualization. We have 2 attackers, and we have 3 servers that we will talk later.
Okay, for the SDN module. In the introduction of SDN, the SDN gives us centralized control over the network, making security tasks like a DDoS detection. Our modules use a Python-based controller and an open flow protocol enhanced by machine learning. So in this overview, this module aims to create a firewall that can detect the DDoS attack by it has 3 resolve. The first is threat limiting, second is block and the last one is the forwarding packet. As you can see the diagram, the first packet coming in a piece and it creates a for loop, and we pull the statistic from for loop to detection, and the detection integrated with random forest model. In the for loop, the most part we have 4 parts, including priority, match rule, action, and statistic. In the match rule, we can see MAC address, IPv4 address, and import. In the action, we have 3 actions that can do. That is forward, block, and red emitting. And the statistic, we have 4 parameters, including duration in nanosecond unit, duration in the second unit, packet count, and byte count. And in the statistic, we pull in every 10 seconds, then save to CSV file. Okay, to detect the DDoS attack, we focus on 3 indicators. Like the first thing is high packet count, second is high data volume or bandwidth or byte count spike, and the last one is short duration with high traffic. The method that we use is the collect data with the for loop statistics CSV file, and we analyze the traffic using the random forest. In the handling traffic that I can see before, that I can talk before, is contain 3 results. The first is block, second is red emitting, and the last one is forward packet. I will skip the forward packet. Let's talk about the block condition. The block condition, when our random forest detected the abnormal traffic or the DDoS traffic with high confidence. For example, the probability that more than 0.9 or the traffic they are the same source is flagged as abnormal multiple times or repeated in a short time frame, we will take action immediately, that is drop the packet. And the rate limiting, we create this scenario to reduce the error of blocking reduce the error from blocking. The condition if the confidence is moderated. For example, the probability that between 0.5 to 0.9. And the action, we will use a meter to limit the flow traffic to 100 gigabit per second. For the machine learning, we use random forest in our system. We have 4 steps, like number 1, collect the data from for loop statistics CSV file, and next is extract feature, like 4 parameter, including packet count, byte count, duration in second, and duration in nanosecond. And next step is train our random forest with normal and abnormal data. The training data we have 2 sources, including public dataset and simulated data set. The simulated data, we use 2 tools, including iPerf to create TCP and UDP plot, and HPing3 to create TCP, SYN, and ICMP plot. And the next step, the last step is prediction. Okay.
So the next model we are talking is server simulation modules. So we will look deep down. So we have 3 components, that is web user and Nginx and backend server. So in web user, we can have both attackers and normal user. So it will send the request to the backend server, but you need to pass Nginx first. So Nginx is like a security gate for our server. So what is the server module in the test bed? It is a simulation application that running on the test bed, and it can like self defend from the moving attacks. So we will look at the component of each things. So we start with proxy. Proxy have a Nginx, and that Nginx have proxy server configuration file, and it also have a file log. And then we send the file log to the database. The database that we are using is InfluxDB, and we have machine learning to detect the attacker in the future work. On the back end side, we have Flux web page, and it can only connect with the proxy. So it means that if you want to send the request to the back end, so you need to send through the proxy server first. It is the example of the file logs. As you can see, it have many information. It have a source IP address, and it have a protocol that receive, that is HTTP, or it can be this one is only except for HTTP port. So it also have from the attacker side that it's using Apache Bench, one tools of the attacker, and we have normal user that want to request here from Mozilla. So how can we integrate it with this server module to the network emulator module? So we develop outside, and then we send a Docker image to the container net. So I was responsible for network emulator side, so I will pull the Docker image, like download it, and then I can use it easily in as a Docker station. So this is the server that we are talking. So server one is proxy, that is Nginx, and server 2 and 3 is two backend server. So we only have 2 attackers here. So in the future we will add more. So next we will talk in attack simulation module. So tools for attacker side, we have HPing3, Apache Benchmark. We have 2 scenarios. The first one is TCP-based attack scenarios. We have spoof IP sync flag. So this one will be the scenario that we're using the fake IP, and TCP flag we are using the real IP address. So next one is HTTP-based attack scenarios. We use this because we want to attack the server, so we try to use the protocol that server is open port to receive. So we use both TCP and HTTP to attack. And we have features that add from the network emulator modules, that it can move station. So this is one of the strategies of the attacker side. So why we need to move? Because in the realistic situation, all the attacker device can move, like botnet, many things that IoT things, or that also in the future that all the device is moving. And we have some papers show that moving pattern can improve the effectiveness of the attack. And the next thing that is important is we can evasion from detection system. Our next step is to integrated machine learning to our work. So we use reinforcement learning to enhance attack efficiency by we have parameters like packet rate and attack types and movement. So we have a set of parameters. So we simulate them and we get the result as a reward. So we will know that what is the best strategies to attack our system. So that's all for today. Thank you for your attention. Do you have any questions?
So, is there one quick question?
So may I ask the team, because this is using the artificial intelligence for the to train the data and for the prediction of the attack. So may I ask the team what kinds of artificial intelligence method you are using? For example, whether it is a traditional one or deep learning. Can you give to show us what kinds of algorithm you are using?
For the SDN module, we use random forest. Yes.
Okay. Okay. So let's go to the next presentation. Thank you very much. And
Thank you.
the last speaker is the Professor Muhammad Ibrahim from University of Haripur. The presentation will be online. The Professor Muhammad Ibrahim, are you ready?
Hi,
Okay.
hi everyone. Yes, I'm ready.
Yeah. Oh, so can you share your slide?
I already shared your slide. May I share here?
Yeah. Please share.
Oh,
Please show
okay,
Please show your slide.
okay. Are my slides shared with you?
Yes. Yeah, I can see it. So would you start the slideshow?
Okay. Thank you very much for giving me a chance to present a work. My presentation is basically related to give you some brief overview about the privacy issues in LLMs and what kind of techniques basically can be applied in order to ensure the privacy preservations of the data. Like, for example, the differential privacy and different techniques which are currently used and how they can be used in order to protect the privacy of the LLMs, because LLM is a publicly model, and if it is applied to some public data, so in that case privacy issues can be arised. So the contents of the presentation will be starting with the introduction of the LLMs, some known issues related to the privacy in the LLMs, what kind of privacy preserving techniques will be used, including the DP, that is differential privacy, and as well as the federated learning. We will also see some couple of studies related to the differential privacy and related to the FL and how they can be like integrated in order to provide a better, robust privacy preservation technique. We will also see some challenges that are related to the deployment of the differential privacy and federated learning in order to in order to preserve the privacy of the data in the case of LLM. And finally, we will see some conclusions and future work that can be done if someone is interested to explore this area. We are also exploring this area because we haven't done much work in this area, but currently one of my PhD student is basically started working on the LLMs, especially on the scalable, some problems related to the LLMs, how training can be improved. And the other student, which had just started work on the privacy issues of the LLMs. So introduction, we already know about OpenAI and some Google Birds. These are the model which are basically giving us prompt-based responses to the user. User provide them the text and they provide us the response. These are very strong models which assist us in many different areas. But problem is that there are some privacy concerns. And before deploying the LLMs to some of the public data, we need to first ensure that our privacy remains the consistent. So a problem is we will also see some like what are basically the privacy preserving techniques and what is the importance of those techniques. Then we also see how we can implement some robust privacy measure in order to protect the data. Though some of the privacy issues which are generally explored in some of the papers are related to the data leakage and the model inversion attacks. And in case of data leakage, some of the, for example, if a model is trained on some data, so in that case, the attacker can get information from the trained model about some sensitive data. So in that case, the attacker can reconstruct construct the training data which basically require privacy, because privacy preservation is utmost important. And if a model, if it is trained on a data which contains some sensitive data, so in that case, that data can be like leaked, and the attacker can reveal those data, and it can lead to some unauthorized access, and it can be used for several different points. Similarly, the inversion attack, that is also a attack in which the adversaries, which are basically determined if the data point was used in training, they can if there is some important data in during the training, so the adversary can utilize this information in order to get information about some important data. Also, we will see we know about some challenges related to the ethical and legal challenges, because we need to ensure that those models have a compliance with the GDPR. So we also need to while implementing those models, we also need to ensure those GDPR related to things. Why we need privacy? Because privacy situation is utmost. So we need to first, if we see like in the traditional system, traditional security measures are very limited. They cannot be applied to the LLM. So we need some very specialized techniques so that they can provide a layer of security, which is basically providing them a layer of security in order to ensure the security or privacy of the data. And the conventional security, as we already mentioned, as surface, they cannot cover all the aspects of the LLMs. Also, most of the LLMs are basically deployed on cloud-based AI systems. So we also need to consider those aspects. So as we know, if the data is basically placed on some cloud, so it will lead to some vulnerability related to the data leakage. And we also need to ensure that how the privacy can be used for a responsible AI. Responsible AI in this case means that they should take care about the user demands as well as the privacy of the users. One of the techniques which is basically related to the privacy preservation is the differential privacy. What does differential privacy do for you? So differential privacy techniques provide a framework that in order to control the privacy risk, ensuring privacy in an model, what we do is that we add some noise and in order to ensure the privacy of the data. But the problem is that how much noise. So while deploying any technique, while implementing any technique, we will take care of the things, the aspects including the parameters related to the differential privacy. And those parameters are related to the epsilon, delta, balance, and the utility, because you have to take care about the budget, the privacy budget that is allowed to, because privacy budget provides you how much security privacy you can achieve. Plus, you also have to take care about the utility, because, for example, if you employ a specific differential privacy techniques and having some certain parameters, and if the utility is low, the algorithm, the machine learning algorithm is, for example, trained, and it doesn't give you the accurate response. So in that case, that the utility will be like low. So we need to keep a balance between the privacy as well as the utility. So this will be take care in front of you if you are proposing some technique related to the differential privacy. How we do it, application and training. For example, if you are training a model, so during the training time, you have to deploy it. You have to employ the differential privacy. So differential privacy will basically protect the sensitive data-driven training. And we have to also care about accuracy and privacy. So there is a trade-off. We have to keep the performance of the model intact as well as how much privacy do we need. Or if the data is much sensitive, so in that case, we have to compromise on some performance parameters. So any technique that can maintain a balance between the performance and the privacy is much approved. So while if we are, for example, if we are proposing any technique related to the differential privacy for the LLM, so we have to take care of those things. So DPFX utility, larger data may be needed. This is one of the study which basically what it does for the title of the paper is related to the differential privacy, lowering adaptation of large language models using federated learning. So it basically they presented an approach for the fine tuning of the LLMs. While as we discussed in the previous slide, the problem related to the data leakage. So what it does for you, what it does for the LLMs, that it lead to improve data. It caters the data leakage problem. How it combines the differential privacy as well as the federated learning with low length adaptation to enhance efficiency and security, because we need, as we discussed, we need to two things. One is the efficiency that is related to the performance, and the second thing is related to the security, which is the privacy. So this method ensures improved model adaptability while maintaining strict privacy guarantees. It means, as we discussed, that privacy needs can be different. So this model, the proposed model is basically adaptable. In some cases, if the privacy is high, So in that case, it will fine tune those parameters to provide high level security. And in some cases, if we require some moderate level of privacy, so in that case, we can, like, based on the privacy budget, this model will provide you a better adoptable results. And the results that demonstrates that keeping the balance in the performance as well as the privacy in decentralized environment. Because in decentralized environments, we have to keep different things intact and also to keep the performance intact. This is another technique, which is basically differential privacy next token prediction of the large language model. We know that a token is one of the parameter for the large language model. So what it does, it explores the privacy preserving techniques for the next token prediction. That what will be the next token prediction. So it applies the differential privacy same problem to prevent the data leakage while maintaining the model utility. So this paper also is evaluated with various experiments and providing a performance detail related to the privacy as well as the performance. And the third model, which is basically related to the text rewriting using the masked language model. So what it does, they propose a privacy preserving method for text rewriting using mask. What it does, it integrates the differential privacy to the LLM to ensure that the rewritten text, which is basically provided to the user, maintains the privacy while preserving linguistic coherence. So it will keep the privacy intact while providing a valuable compliance writing language. These are some of the challenges which we need to keep intact is the computational overhead, because the computational overhead need to be improved, need to be keep intact. So the technique must be efficient in terms of the computational overhead as well as providing you the privacy. So differential priority, as we know, if we implement an LLM, so it will lead to the training complexity as well as the resources needed. So what we will do, that parameter selection should be important. So balancing the privacy as well as the performance. What federated learning is? Federated learning is basically training the models. If you have private data at different places, so what we do is that we at different places the model is trained with local models, and then the training is integrated into one model by providing the privacy preservations. So data stays on the local devices. That will reduce reducing the exposure risk. The data is not exposed to the adversaries. Problem is that those updates need to be shared with the integrated model. So in that case, while sharing the data to the model, we have to keep the privacy intact. This is a decentralized approach. So the data set, which is distributed across various places, will be trained while preserving the privacy. In this case, the reducing centralized data dependency is if the model is trained on a single model in centralized model. So in that case, the privacy risks are very high level. But in case of the federated learning model, we will get the balance. These are some of the techniques. For example, the first paper, which is integrated federated learning and differential privacy to train the language model on a mobile keyboard. So this is the performance of the model should be intact in this case as well. These are some of the challenges of the federated learning model in LLMs. For example, communication cost and latency. The model will be trained at some different locations, but the problem is that when we when the model is distributed across different areas and the model updates are shared. So in that case, the communications cost should be like optimized as the latency can occur. So in that case, we will have to take care of these things while maintaining the privacy as well as the performance. Frequent updates are increases communication overhead. For example, if a model is trained again and again, and that the updates need to be sent to the integrated model. So in that case, it will lead to the latency, as well as data heterogeneity. As different devices have different like heterogeneity, the hardware at one area may be different and the other area may be different. So in that case, we also have to take care about the device models. Conclusion and future work, we already seen that the advances of LLM has lead to like improved response to the user, but the problem is related to the privacy. So in that case, we have to find techniques, solutions related to the differential privacy as well as the federated learning models in order to ensure the privacy while maintaining the utility of the model. There are some other challenges, for example, the computational overhead, the parameter tuning, and the potential adversarial attacks. So these attacks need to be kept intact while proposing any technique. As well as we have to take care about the performance related to the differential privacy and the federated learning model. For example, to reduce the performance trade-off, exploring the hybrid usage of the privacy preservation techniques, and some deployment regulatory problems. If there is any question, thank you very much for listening to the presentation.
Thank you. And are there any questions or comments? Okay. All right. So yeah, we have spent too much time. Thank you so much, Professor Ibrahim. Thank you.
Thank you.
So this is the end of this sessions. So thank you for coming the AI-driven networks working group. Thank you very much.